We've got one more case of regular polygons that we're going to look at, and that's the case where we're only given one length. So we're either given the side, the radius, or the apothem, but we only have one of them, which means that we can't use Pythagorean theorem because that requires two lengths. But what we can do is use trigonometry if we have an angle. So the easiest angle to look at is the central angle of any of these. So first, for any of these regular polygons, those center angles all add up to be 360 degrees. So if I go all the way around in the center, I've got 360 degrees. So if I'm trying to figure out one of these angles, that means I'm going to take 360 and divide by the number of sides. So since I have 3 sides here, I'm going to divide by 3, and I get that this angle right here is 120. If we're going to apply this to finding the area of our regular polygon, that means that we need to actually cut that in half. What we actually want is the triangle that has the apothem as a leg, half of the side as a leg, and then the radius as the hypotenuse. So instead of being 120, we're actually going to cut that in half and say that the angle that we need for the top of this triangle is 60 degrees. So this happens to be a 30, 60, 90. And then you could use your special right triangle skills if you wanted to. Okay, so let's look at the square or regular quadrilateral. If we're finding that big angle, then I'm taking 360 divided by the number of sides. But then cutting that in half is what's going to give us the angle that we need in order to use trig. So we're going to have that 45-degree angle. It is a 45, 45, 90. And then one more, looking at a pentagon. My big angle here, I'm going to take 360 and divide by 5. Which is 72. So that's my big angle. But then dividing it by 2 is going to give me my angle of 36, which I'll use for that triangle. So for example 4, still looking for the same information. I need the apothem, the perimeter, going to put that into my formula for the area. But like I said, we only have one length. So I've got this 8 feet. I'm going to go ahead and draw in the triangle that I will use to find the apothem. Remember, I don't need the radius for my formula, so unless my radius is in the problem and I can use it, I don't need to find it. So I'm only needing to find the apothem in this situation. And it definitely is going to help me to redraw this triangle much larger. That's also going to allow me to go ahead and cut that 8 in half because my side length there is actually just 4. And I'm looking for the apothem. So a lot easier for me to see. This is what's going on. And this is where our angle comes into play. So if I'm using that central angle information that we just learned, this is, let's see, 1, 2, 3, 4, 5, 6. It is a hexagon. So we're going to take 360 and divide by 6 to get 60. And then remember, we want to divide that in half, because that 60 degrees is this whole big angle, but if we divide it in half, it's going to tell us that this angle right here is 30. So this is a 30, 60, 90. If we remember how to go from short leg to long leg, I could just use my shortcut for this. So I'll show you both ways. If I remember the shortcut, then that tells me from short leg to long leg that I multiply by radical 3. So I would just automatically know that my apothem is 4 radical 3, and then I can work the rest of the problem. If I did not remember my special right triangle, so that's where it's helpful a lot faster, but if I didn't remember, I could use trigonometry, and if I have this 30-degree angle right here, and then my 2 side lengths are both legs, so I should be using tangent. So I've got the tangent of 30 degrees is going to be equal to my opposite over adjacent, so 4 over a. I have to adjust this a little bit. So my tangent of 30 equals 4 over a. and then I'm cross multiplying and then dividing by the tangent of 30. And when you use your calculator, it's not going to come out as a radical. At least my calculator is not fancy enough to do that. You're going to get about 6.928. And this is the equivalent of 4 radical 3. It's not as exact because 4 radical 3 is an exact value, where this one we had to round. But they are going to be close enough that it's not going to matter which one you use. I would go to 3 decimal places here though. So for your apothem, you could use 4 radical 3 or the 6.928. For our perimeter, we had a side length of 8 and then 6 sides, so our perimeter is 48. And then now using our formula, and then let's go ahead and round to 1 decimal place here. So it shouldn't make a difference whether you're using that decimal approximation or the 4 radical 3. But you should get 166.3, and this was feet. So for our last example, we've got a pentagon with a radius of 7 centimeters. So for this one, I'm going to need to find the apothem and a side length. So I have 2 things to find. Still going to focus in on that triangle. So redrawing it larger. I only know the hypotenuse. To find that angle, hopefully we're kind of getting the hang of that, taking 360, dividing by 5. In fact, we did this one earlier, so you could even use what we already found. And then dividing it by 2, because remember that 72 degrees is that bigger angle, but dividing by 2, we get 36. So we can see from this one, since it's not a 30, 60, 90, and it's not a 45, 45, 90 either, so not special, I have to use trigonometry for this. So I'm going to go ahead and give myself 2 variables. So I've got an x and an a. So let's find x first. So if I'm using my 36-degree angle, using x and 7, my trig function should be sine. We've got the sine of 36 equals x over 7. So then just multiplying both sides by 7, you should get about 4.114. About 3 decimal places. To find a, very similar, but now I'm going to be using a different trig function because I have the adjacent and the hypotenuse. So I'm going to have cosine of 36 equals a over 7. Very similar process. So 7 times the cosine of 36 this time. It's 5.663. And I do always have students that ask me, once they find one of these, if they're allowed to use Pythagorean theorem to find the other one. And yes, if you found the first one correctly, then using Pythagorean theorem should be fine. If you don't find that first one correctly though, it's going to make them both incorrect. I don't know. I feel like once you do trig with one of them though, using trig for the other one is not too hard. I wouldn't want to use Pythagorean theorem at this point with that long of a decimal. Anywho. Now that I've got my apothem and then half of my side, remember that x value was only half of the side length. So that means my apothem is that 5.663, but my perimeter is going to be 2 times 4.114 times the number of sides, so times 5. So I've got, since I'm multiplying by 10, I'm going to have 41.14 for my perimeter. And now I can go ahead and use my formula. And rounding to 1 decimal place, we should get 116.5. And this was centimeters.